Okay, so kind of the opening question is, can you take the derivative of the function defined by the product of these two factors, the 2x minus 1 and the x plus 3, by taking the derivatives of each of them and then just multiplying them together? And pretty much, if you start to go and distribute this, you'll have 2x squareds, looks like 5x's, and something else. So we're looking at something with like 4x and some other number, which is certainly not the same as 2. So what we can see is that we're going to need some special rule to take the derivative of a product. So the theorem is that the derivative of the product, how we do that is, okay, we're going to start by taking the derivative of f and leaving g the same. Then we're going to add in the derivative of g with f left the same. Now, I'm not going to include the proof today because there's not going to be enough time. But that's the type of thing that I'm going to do when we come back for that after lunch meeting next week. No, week after. So whenever that happens, I'll come back with a few proofs. And, of course, some carefully selected multiple choice questions. Now, keeping that up there, highlighting. Let's start with an example. Okay, x to the third cosine x. Find the value of dy dx at the point where x equals 2. Now, I usually recommend to go with the easier of the two easier of the two factors first when doing the product. But both of these are pretty easy, so it doesn't really matter which one to choose. I'll start with x to the third. I know that the derivative of x to the third is 3x squared, so I'll start with that. And I'll leave cosine x the same. I'm going to add in, leave x to the third the same, and then take the derivative of the second one. The derivative of cosine is negative sine. Okay, but they asked for the value of the derivative at the point where x equals 2, so what I'm going to do is I'm going to come in and I'm going to plug in x equals 2. So dy dx at the point where x equals 2 is going to equal 3 times 4 times the cosine of 2 radians minus 2 to the third is 8 times the sine of 2 radians. And that's as far as we're going to get. You could make it 12 times the cosine of 2 radians, but that's an exact solution. Stop there. Next, we're going to write an equation for the line tangent to the graph of the function at x equals pi. Here I've got one on the left. I'm going to give you all another one to do after this on the right. Well, I'll walk through it. Remember that in order to get a tangent line, we need ingredients. We need the point, and we need a slope. Okay, to get the point, it's going to be, we're going to need f of pi. And to get the slope, we're going to need f prime of pi. Okay, well, f of pi is going to be 2 pi times the cosine of pi is going to be negative 2 pi. So our point is pi and negative 2 pi. The slope, okay, f prime of pi, okay. Well, I need to find f prime of x first. So that might be where I drop this down here and say, well, f prime of x is going to equal, if you take the derivative of 2x first, that's 2 times cosine x, leave cosine the same. And then I'm going to add in, leaving 2x the same, take the derivative of cosine, and that's negative sine x. Okay, included in myself another room here, but I'm going to say that that's equal to 2 cosine x minus 2x sine x. F prime of pi, when I plug in pi, I'm going to get 2 times the cosine of pi is negative 2 minus 2 times pi times the sine of pi, which is 0, Okay, so that's just negative 2. Now that I've got a point and a slope, I'm ready to write down the equation of the tangent line. Y minus negative 2 pi is going to equal negative 2 plus u times x minus pi. Okay, this next one I actually don't need you to write down a tangent line for. I'm going to just ask you to take the try to make. So I'm going to ask you to write a formula for g prime of x using the product. The first thing being 3 and the second thing being cosine of x. Okay, so when I took the derivative of 3, that's 0, and I left cosine x the same. Then I added in, leaving 3 the same, multiplying by the derivative of cosine, which is negative sine, and I get negative 3 sine x. The point I'm trying to make here is that you don't have to use the product rule for a constant multiple. You can, and it won't give you the wrong answer, won't give you a bad derivative, but it's just not necessary. We don't need it. And, you know, traditionally what I've seen is that this is kind of a lesson best learned the harder way, where you just keep doing it until you realize that there's no point in doing this. You're just going to stop. The next thing we're going to talk about is the line normal to a graph. Okay, so we don't know what a normal line is yet. So a normal line is going to be perpendicular to the tangent line at that point of tangency. So give an equation for the line normal to the graph of the function at t equals pi over 2. Okay, well, first I'm just going to rewrite this as x equals 2 times t to the 1/2 times sine of t. Okay. Definitely want to use the power rule on that. You know, they have a square root of the function. Okay, so the first thing I'm going to need a point. And that's going to be pi over 2, but I'm going to need x of pi over 2. So that's going to be 2 times the square root of pi over 2 times the sine of pi over 2, which is just 1. And that's the square root of 2 pi. And I know because I did this yesterday, but also you can check that, you know, you can square root of it and see that that's actually the same. But I like the square root of 2 pi, that's like kind of compact, I can write that. It's not too large. So I've got a point, now I need a slope. But in order to get the slope, first I need to take the derivative. So x prime is going to be, well, I'll take the derivative of 2t to the 1/2, and that'll be 1t to the negative 1/2. Leave sine the same. I'm going to add in, leaving 2t to the 1/2 the same, take the derivative of sine t, which is cosine t. And now, in order to get the slope, I say it's perpendicular to x prime of pi over 2. Okay, so that means basically we're not going to do that one. It's going to be perpendicular to, okay, I'm going to plug in pi over 2 for t. So 1 over the square root of pi over 2, that's pi over 2 to the negative 1/2 power, times the sine of pi over 2, which is going to be 1, plus 2 times t to the 1/2, so that'll be 2 square roots of pi over 2, times the cosine of pi over 2. But the cosine of pi over 2 is 0. So that's nice. And so really what this is, I'm going to clean this up, this is all gone, and 1 over the square root of pi over 2 is going to be the square root of 2 over pi. Remember how we get a perpendicular slope from, basically like algebra 1 or something? We flip it and we make it negative. So that gives us negative 1 over the square root of 2 over pi. And you can leave it like that if that's how you feel. It's also going to be the negative square root of pi over 2. However you feel. Okay, but that's our slope. We've got our point up here being pi over 2 square root of 2 pi. So a normal line would be y minus the square root of 2 pi is equal to negative square root of pi over 2 times x minus pi over 2. Alright. So the quotient rule. Okay. Now we need a quotient. Okay, so, you think about y equals x squared divided by x. That's y equals x. I guess where x isn't 0, but it's y equals x, which is going to have derivative 1. Which is not the same as 2x divided by 1. Okay, so again, we're going to need some special quotient rule to deal with this situation. So, for f divided by g, it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And the thing is, when you're committing this to memory, I really don't recommend remembering it in terms of f and g, because what we've seen recently on the AP exam, I want to say it was like in the 2016 or something, on the AB, where they're testing a lot of derivative rules, was we saw that they gave us g over f, and they had us calculate the derivative of that. And they said they caught a bunch of people who were just regurgitating the formula as I wrote it, because they were used to f divided by g, instead of switching. So what I recommend you remember is really bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's really going to be the way to go. And I'm sure, if you hit the internet or look on YouTube or something there, it's going to be mnemonic devices or something to help you remember. But really, it starts with the bottom times the derivative of the top. Then you can probably remember the result. Alright, so let's just put this to use. Y equals x divided by the square root of, just x squared plus 1. Find dy dx. Well, we can find dy dx. I'll leave that quotient. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom square. And now if you wanted to, write this more cleanly, this would be x squared plus 1 minus 2x squared. So it's negative x squared plus 1 over. Okay, as to the question of which values of x is the function differentiable, it'll be differentiable just as long as dy dx is defined. And the only thing that I can see that would prevent dy dx from being defined would be if the denominator was 0. So what I'm going to do is I'm going to check and see, where does the denominator equal 0? And that would be where x squared plus 1 equaled 0, which is just where x squared equals negative 1. And since this is a course in functions that take in a real variable and give you back a real variable, we're going to say there aren't any places where the function fails to be differentiable. So it's differentiable for all real numbers. But that kind of makes sense, because if we look at the original function, it's not undefined anywhere. It doesn't have any vertical asymptotes, doesn't have any discontinuities. So it'd probably be hard-pressed to find a place where it is. All right. So the next one, I want y'all to take the derivative of this using the quotient rule, just like we did with the product rule, making the same point. And we can see that, again, because the derivative of a constant value is 0, using the quotient rule for, division by a constant is not going to be all that useful. Okay? Yeah, it's not going to lead you to a bad derivative or error or anything. It's just not necessary. It just happens to work out that way. And, alright, so there you go. That's how next to those. Alright, find the points at which the graph of the function has a horizontal tangent. Okay? I think, in the interest of time, I might scroll past these. Yeah, to the table of data. Okay, horizontal tangent. We did those last time. They're going to be on the homework again. We're trying to find where the derivative is. If they asked where the tangent was vertical, well, we're not ready for that yet. I said that we were, but really, if the denominator of the derivative is 0, it's likely going to be a vertical asymptote. And later on in a couple of units, we'll look at curves that actually do have nice vertical tangents. It's just, we know that cube root of x has a vertical tangent at x equals 0. You would need the derivative to be undefined while the function was also defined in order for it to be, just like, yeah, you don't need to worry about that. Right now, the table of data. This table did look really nice, but then I imported it into OneNote. Something bad happened. So what we're going to do is we're going to take the derivative of p of x, and we're going to use the data in the table to find p prime of 4. So really what the table is giving us is it's giving us just enough information about f, g, and their respective derivatives. So start with the derivative of p. Take the derivative of the first, leave the second one the same. Then add in the derivative of the second one while leaving the first one the same. So p prime of 4 is going to be f prime of 4 g of 4 plus g prime of 4 f of 4. And now we're just going to go and get all of these data points from the table. Okay, f prime of 4 is pi over 2. G of 4 is negative 3. G prime of 4 is pi. And f of 4 is 9. Okay. Now that I've got all those, I'm going to figure out what this is. And, you know, if this was like the free response portion of the test or something, you could just stop right there and that would be fine. But if you needed to recognize, say, different multiple choice options, what you would do is you'd say that was negative 3 halves of pi plus 9 pi. If I have 9 and I lose 1.5, I'll have 7.5, so that's 15 pi. Here, already, I've got g divided by f, so it's like we cannot get comfortable with the, you know, g prime f minus f prime g over g squared. We can't do that. That's not going to be sustainable in the long run. So first I'm going to take the derivative of q. Bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Okay, so q prime of 9 is, I'm going to need to get all of this data from the column that has x equals 9. Alright, so q prime of 9 is going to be equal to f of 9 is 4, g prime of 9 is negative pi over 2, minus g of 9 is 2, f prime is negative 3, divided by f of x squared, so that's going to be 16. So that's negative 2 pi plus 6 over 16. And yeah, you could simplify that if you wanted. That would be fine. Alright, now, the graph problems. So there will be problems on the homework tonight that have this exact same graph on them. In general, it's going to be piecewise linear because you're going to have to find values from the graph and you're going to have to find derivatives from the graph. The nice thing about that is that, you know, you can just look and kind of count squares and do rise over run and see that, you know, maybe if they asked for what the derivative of f was at x equals 9, it would be over 1 up 2. That would be f prime equals 2. So, y'all give these a shot. The derivative of f times g at the point where x equals 4 and the derivative of f divided by g at the point where x equals 8. Do one of them. I'll try to work both of them real quick while it's frozen, and then you can check. Alright, so that's what I've got. And then in the last couple of minutes, I'm just going to tell you a couple of derivatives that could help you solve some multiple choice questions tonight that are suggested. And I really do suggest that you start doing some of the multiple choice questions. So here's a couple of more derivatives. Okay, so the derivative of e to the x is e to the x. And the reason why, I'll show you some evidence next time at the beginning, but the proof of it, comes down to really what the definition of e is. And really that's my answer for you. That why is the derivative of e to the x e to the x? That's what e is. I've got if you want, I can show you a video that's more specific on this, but you need to know that. And then you also need to know that the derivative of log x, when I say log, I mean natural log, is 1 over x. And those will probably be pretty useful if you decide to dive into some of the multiple choice questions tonight. That'll help you out with some of the multiple choice and pure response questions. The book probably won't hit this because they do the transcendental functions later. Alright, y'all have a good one. I'll see you on Friday. Show's up.